Public health and environmental science have a strange accounting problem. The final product of the work is the absence of harm. Success lives in the catastrophes that were avoided. An accurate hurricane track means families evacuate early. A properly mapped coastline means a ship reaches its port without hitting the hidden rocks. Measuring these invisible outcomes requires extreme patience, which is exactly what researchers committed to in the 1970s when they launched the Harvard Six Cities study. Over 16 years, they tracked the lives and medical histories of 8,000 residents living across 6 average American towns. The researchers wanted to isolate the true, long-term cost of industrial pollution. They continuously monitored the specific air quality in each town, recording the precise concentration of emissions hovering over the neighborhoods. Then, they watched for over a decade, matching the health outcomes and mortality records of the participants against the air they breathed every day. Establishing a continuous, unbroken baseline of data takes decades of quiet observation. But having that exact historical record is the absolute baseline requirement for a government attempting to protect its citizens from threats they cannot easily see. In 1993, the study's data revealed a distinct threat tied to fine particulate matter, commonly known as PM2.5. These are microscopic fragments of pollution, less than 2.5 micrometers wide. They are small enough to slip past the defenses in the nose and throat, penetrate the bloodstream, and trigger systemic inflammation. This chart tracks the specific mortality rates across the study. On the left is the baseline for the city with the cleanest air. On the right is Steubenville, Ohio, a heavily industrial steel town. After adjusting for smoking and other variables, the conclusion was stark. Residents breathing Steubenville's heavy PM2.5 pollution were dying 26% sooner than those in the clean air city. This block of data was irrefutable. In 1997, the Environmental Protection Agency used the Six Cities findings to establish the first-ever national air quality regulations, specifically targeting fine particulate matter, changing the operational requirements for American industry. The measurable aftermath proved the science correct. As the new regulations took hold, particulate concentrations dropped nationwide. Extended follow-up studies of the original 6 towns confirmed that as the air cleared, the residents' risk of early mortality dropped proportionately. When the slow machinery of scientific observation is funded and allowed to operate continuously, the result is literal. It translates directly into extended human lifespans. In the 2025-2026 federal budget cycle, the logic of continuous measurement met with political hostility. The long legacy of patient, invisible science was halted. The executive branch initiated an immediate dismantling of the EPA's internal science infrastructure. They announced the abolishment of the Office of Research and Development, the independent scientific corps responsible for synthesizing the complex environmental data that justifies clean air and water regulations. Simultaneously, administrators targeted the National Oceanic and Atmospheric Administration. Budget proposals drafted that spring sought a 74% funding cut to NOAA's Oceanic and Atmospheric Research Arm, a move designed to eliminate thousands of scientific roles across federal laboratories. These cuts bypassed specific environmental regulations and catch limits to target the underlying instruments and experts required to measure the physical world.
Eliminating the research line effectively blinds the regulatory state. Without the experts who manage the instruments, the government loses its ability to see the systems it is tasked with managing. To justify this structural dismantling, political appointees pointed to a concept they called secret science. They argued the government should never issue regulations based on data that could not be fully published and made open to the public. The flaw in that argument is that the most vital epidemiological studies rely entirely on medical privacy. The researchers tracked hospital records, specific causes of death, and residential addresses. By law, those confidential health records cannot be publicly published, meaning a strict open data rule functionally bans the government from using the best available public health science. The second major justification for gutting these agencies was framed as basic economics. Administrators argued that firing scientists and closing federal laboratories was a necessary exercise in government efficiency and cost saving. Firing the data gatherers snaps the continuous time series.
To know if a sudden drop in a fish population is a temporary natural variation or the start of a collapse, researchers need decades of uninterrupted context to compare it against. An ecological record that runs continuously for 90 years takes exactly 90 years to build. Breaking the chain of observation for even a single season destroys the historical context needed to make sense of the present. By late 2025, the physical fallout of these severed data baselines was already playing out in the commercial waters of Alaska. Following deep personnel cuts, the Little Port Walter Research Station in southeast Alaska went dark, forced to cancel its work after more than 90 years of continuous operation. In just months, NOAA's Alaska Regional Office lost roughly a quarter of its entire workforce. Those staffing losses triggered an immediate operational failure. Without enough scientists and fish aging technicians to analyze the incoming biological samples, the crucial 2025 annual stock assessments for the multi-billion-dollar Bering Sea and Gulf of Alaska fisheries could not be completed. Without a current mathematical assessment, the government loses the ability to verify reality. Managers have no way to know if a targeted fish population is currently thriving or teetering on the edge of a collapse. Consider the position of a commercial Alaskan fishing boat preparing for the 2026 season. The ocean on the surface looks exactly the same as it did the year before, but the state of the population beneath the hull is mathematically unknown. Because the 2025 science was aborted, regional fisheries managers were forced to set the 2026 commercial catch limits based entirely on stale, outdated data from 2024. A fisherman planning an intensive season on last year's map takes on the risk of the unknown. If the stock has actually declined over the last 12 months, harvest limits set for a healthy population can lead to unintentional overharvesting, pushing a fragile ecosystem toward a point of no return. Cutting the measurement infrastructure shifts the entire burden of the unknown onto the industry. The initial savings on laboratory salaries disappear when a multi-billion-dollar fishery is managed using guesswork. Dismantling these research systems removes the data-driven map that citizens and businesses rely on to navigate an increasingly volatile future.